Hello learner, it is time for our SHS 3 Core Mathematics program. This is brought to you by Center for National Distance Learning and Open Schooling, CENLOS. I am Ben. We have already learned how to find the surface area of some solids or three-dimensional figures in our previous lessons. In this lesson, we shall discuss about the surface area of the pyramid. In this lesson, you should be able to calculate the surface area of a pyramid. Pyramids have long history. One of the 7 wonders of ancient world is the Pyramid of Giza in Egypt. The pyramids in Egypt were built about 4,557 years ago. This diagram is one of the Egyptian pyramids. It has a square base with slant height of about 755 feet and a height of about 481 feet. One may ask, why did the Egyptians build the pyramids? They were burying their pharaohs in them. A pyramid is a three-dimensional object that has triangular faces and a base that is a polygon. So the base can be any of the types of polygons that you have learnt already. The triangular faces meet at a point called the vertex. You remember the vertex of a cone. Pyramids also have vertices. The height of the pyramid is the perpendicular distance from the vertex to the center of the base. This diagram shows a pyramid with its various parts. Like we learned under cones, we have the vertex, we have the height, we have the slant height, and we have the triangular face. The triangular face of the pyramid is the slant height. When the base of a right pyramid is a regular polygon, then the slant height of the right pyramid is the height of one of the triangular faces. Let's look at types of pyramids. The name of the pyramid is determined by the shape of the base. So depending on the base, the type of polygon, then the pyramid will have its name. For instance, if the shape of the base is a triangle, then it is referred to as a triangular pyramid. This is an example. You can see the base of the pyramid being triangular. A triangular pyramid is also referred to as a tetrahedron. In fact, a regular tetrahedron has 4 equilateral triangles. If the base of the pyramid is a square, then it is a square pyramid. And an example is shown on the screen. Here are some other examples of pyramids. You have a right rectangular pyramid, meaning it is on a rectangular base. You have a right pentagonal pyramid, meaning the base is a pentagon. Let's look at the net of regular pyramids. As we know from our previous lessons, a net is any 2-dimensional figure that can be folded to form a 3-dimensional shape or a solid. We shall consider the net of some pyramids. The net gives the various figures forming the pyramid. We can see the net of a right triangular pyramid. Then there is also the net of a right rectangular pyramid. Now you want to look at how to find the total surface area of a pyramid. The total surface area of a pyramid can be calculated by finding the surface area of each face making the pyramid. Let us consider a right square pyramid, as you can see on your screen. We established that the net is made up of a square base and 4 equilateral triangles. You can see the net of the pyramid. We first find the area of one triangle and then multiply by 4 to get the total sum of the areas of the triangles. We then find the sum of the area of the base and triangles to obtain the total surface area of the pyramid. Let us find the area of triangle ODC. And we know from our previous lessons that the area of a triangle A is half multiplied by the base multiplied by the height. So from our triangle, A is equal to half multiplied by DC, which is the base, multiplied by OE, which is the height. Therefore, for the 4 faces, we multiply the results by 4. So the total surface area of the sloping faces will be 4 multiplied by half, multiplied by DC, multiplied by EO. And that means the total surface area of the sloping faces will be 2 times DC times EO. That is not the end. We need to find the area of the base. Now, in this question, the base is a square. So you find the area of a square, and that is given by area equals the length multiplied by the breadth. Because it's a square, we are going to have length times the length. So area is equal to AB multiplied by BC. Or, because AB is equal to BC, which is the length, then our area will be equal to L squared. So to get the total surface area of the pyramid, that is the faces and the base, we are going to get 2 multiplied by DC multiplied by EO plus L squared. That is the faces and the base. But note that if the total area excludes the base, then we are going to have only the faces. In that case, your total surface area will be equal to 2 times DC multiplied by EO. We shall now consider how to calculate other parts of the pyramid. Let's look at how to find the length of the sloping face. As you can see from your screen, from the pyramid, OE is the height of a sloping face. We will consider the triangle ODC. OE is the sloping height, and considering triangle EOC, which is a right angle triangle, we apply the Pythagoras theorem, and that gives us the length of OE squared plus the length of CE squared to be equal to the length of OC squared. Therefore, the sloping height OE is given by the length of OE equals square root of OC squared minus CE squared. Let's look at how to find the angle between the base and the sloping face. You can see from your diagram. From the diagram, the angle theta is the angle between the base ABCD and the sloping face ODC. Considering triangle EOP, we can find the angle theta using one of our trig ratios. Here we can apply tan theta. So you get tan theta equals the length of OP divided by the length of EP. And that will give us theta equals tan inverse of OP divided by EP. Now let's look at how to find the vertical height of a pyramid. We can also find the vertical height OP by considering the triangle EOP. Again, we apply the Pythagoras theorem, and we have the length of OP squared plus the length of EP squared to be equal to the length of OE squared. Therefore, the vertical height OP is given by OP equals square root of OE squared minus EP squared. That is good. A lot of formulas. Let's continue finding the sloping edge of a pyramid. You can see in your diagram. From the diagram, OC is a sloping edge. So to calculate OC, we are going to consider triangle POC, which is also a right-angled triangle. So again, we apply our Pythagoras theorem to help us find the OC. So from the diagram, we can have OP squared plus PC squared to be equal to OC squared. Therefore, the sloping edge OC is given by the length of OC to be equal to the square root of OP squared plus PC squared. That is good. Now that we can calculate the length of the sides and some angles in the pyramid, we are now in the position to solve some questions on the pyramid. Let's take our first example. A pyramid has a square base PQRS of side 10 meters, and each of its sloping edges are of length 12 meters. Calculate the total surface area of the pyramid. Like we did in cone when we were solving problems, the first step is to try and draw your diagram. We find the area of OSR. Considering triangle OEC, we apply the Pythagoras theorem to find OE. So from the triangle, we have OR squared equals OE squared plus ER squared. That means OE squared is equal to OR squared minus ER squared. If you do our substitutions, we have the length of OE equals square root of 12 squared minus 5 squared. And that will simplify to OE equals square root of 144 minus 25. Therefore, our OE is equal to 10.909 centimeters. So we conclude that the height of the triangle is 10.909 centimeters. We can now find the area of the triangle using our formula half base times the height. So the area is equal to half times 10 times 10.909. Therefore, our area is equal to 54.545 centimeters squared. We can find the area of the square, and that is length times length. So you have 10 times 10. Therefore, the area of the base is 100 centimeters squared. Now, to find the area of the triangles, since they are equilateral, we multiply by 4 to get the area of all the faces. And then we add the base to it to get the total surface area of the pyramid. So the total surface area is equal to 4 times 54.545 plus 100. And if you do the multiplication, you get 218.18 plus 100. Therefore, our total surface area is equal to 318.18 centimeters squared. That is interesting. Let's look at the second example. The diagram represents a right rectangular pyramid. Find A, the total surface area, the height of the pyramid. Let's look at the solution. We have two different triangles whose bases are 14 centimeters and 10 centimeters. we find the height of the triangles. Let's consider triangle with base 14 centimeters. Now let's consider triangle ABD and apply the Pythagoras theorem to find the height AD. Using the Pythagoras theorem, AD squared plus DB squared equals AB squared. If you do our substitutions, then we are going to have AD squared plus 7 squared equals 12 squared. And that will simplify to AD squared equals 144 minus 49. If we simplify this, we are going to have AD squared equals square root of 95. Therefore, our AD is equal to 9.75 centimeters. Now, the area of triangle ABC is half base times height. So, if you do our substitutions, then we have area of triangle ABC to be equal to 1 over 2 multiplied by 14 multiplied by 9.75. Using our calculators, the area of triangle ABC will be equal to 68.25 centimeter squared. Again, let's look at the triangle with base 10 centimeters. We pick one of the right angle triangles, which is ALZ, and we apply the Pythagoras theorem to find the height AL. From the Pythagoras theorem, you have AL squared plus LZ squared equals AZ squared. If you do a substitution, then we will get plus 5 squared equals 12 squared. And that will simplify to AL squared equals 144 minus 25. Simplifying this, we have equals square root of 119, that's 119. And therefore, AL is equal to 10.91 centimeters. Area of triangle AYZ is equal to half multiplied by 10 multiplied by 10.91. So the area of triangle AYZ, simplifying, is equal to 54.55 centimeter squared. The area of the base is a rectangle, and the area of a rectangle is length times the breadth. So you do our substitution. The length is 14 and the breadth is 10. So the area of the rectangle is 14 times 10. And that will simplify to 140 centimeter squared. Now we find the total surface area of the pyramid. And that is equal to 140 plus 54.55 plus another 54.55 plus 68.25 plus another 68.25. And that gives us a total surface area of 385.6 centimeters squared. Now let's look at the B. We are to calculate the height of the pyramid, which is OA from our diagram. We first find the diagonal BC and then divide the diagonal by 2 to get OB. Let's consider the base of the pyramid and apply our Pythagoras theorem. From triangle BYC, the length YC squared plus YB squared is equal to CB squared. If you do our substitutions, they have 14 squared plus 10 squared to be equal to CB squared. Simplifying that, we have CB equals square root of 296. And that gives us CB equals 17.20 centimeters. Therefore, the OB that we are looking for is equal to 17.20 centimeters divided by 2. And that gives us 8.6 centimeters for our OB. We can now apply the Pythagoras theorem to find the height OA. By the Pythagoras theorem and from the triangle, the length OA squared plus the length OB squared equals the length AB squared. If you do our substitutions, we have OA squared plus 8.6 squared to be equal to 12 squared. Simplifying that, we have OA equals square root of 70.04. And that will give us OA equals 8.37 centimeters. That was very easy. Let us look at the third example. In the right square base pyramid, V is vertically above the middle of the base. AB is equal to 12 centimeters and VC is equal to 25 centimeters. Find A, the length AC, B, the height of the pyramid, C, the angle between the line VC and the base ABCD, D, the total surface area of the pyramid. Let's look at the solution. Considering the base, we apply the Pythagoras theorem to find the length AC using triangle ABC. So we have the length AB squared plus BC squared equals AC squared. If you do our substitutions, we have 12 squared plus another 12 squared equals AC squared. And that will simplify to AC squared equals 144 plus 144. And that gives us AC equals square root of 288. Taking the square root, we have AC equals 16.97 centimeters. Now look at B. Now B says find the height of the pyramid. And from the pyramid, the height is OV. But we note that OA is equal to AC divided by 2. So if you do the substitution, we have OA to be equal to 16.97 divided by 2. And that will give us 8.49 centimeters. Considering triangle VAO, we can apply the Pythagoras theorem. From the diagram, OA squared plus OV squared is equal to VA squared. If you do the substitution, then we are going to have 8.49 squared plus OV squared equals 25 squared. Simplifying, we have OV to be equal to square root of 552.92. And that gives us OV equals 23.51 centimeters. The next question, let's consider triangle VOC. We are to find the angle theta. Again, using our trig ratios, we can use tan theta equals OV divided by OC. And that will give us theta equals tan inverse of 23.51 divided by 8.49. And using the calculator, you get our theta to be equal to 70.14 degrees. The next one is to find the total surface area. As we have learned already, the total surface area is made up of the faces, which are triangles. So you pick one of the triangles. From the diagram, triangle VAB is an isosceles triangle. The line OV is dividing the base AB into two equal parts. Hence, OA should be equal to OB, and that will give us 6 centimeters. Looking at triangle VOB, we can still apply our Pythagoras theorem to find the height OV. From the theorem, OV squared plus OB squared is equal to VB squared. And that will mean OV squared is equal to VB squared minus OB squared. When we do our substitutions, we have OV squared equals 25 squared minus 6 squared. And simplifying, we have OV squared equals 625 minus 36. And that will give us OV equals square root of 589. Therefore, the height of OV is equal to 24.27 centimeters. We now find the area of the triangle, which is half times the base times the height. So we do our substitutions, and we have A equals half times 12 times 24.27. And that gives us 145.62 centimeters squared. Since the pyramid has 4 equal triangles, it means the areas are equal. So we multiply the area by 4 to get the total area for the triangles. So we get our total surface area to be equal to 4 times area of the triangles plus the area of the base. And that will give us 4 times 145.62 plus 12 times 12. And that will simplify to 582.48 plus 144. Therefore, the total surface area is equal to 726.48 centimeters squared. Good. That has been very interesting. In this lesson, we have learnt 1. How to calculate the total surface area of a pyramid. We have also learnt how to draw the net of a pyramid. Again, we were able to label the parts of the pyramid. This brings us to the end of our discussions on surface area of pyramid. In our next lesson, we shall look at the volume of a pyramid. I hope you have learned a lot, and you will keep practicing a lot more questions on all that we have been discussing on this program. Join us again for the next lesson. See you then. Goodbye.